Hello, this is Mr. Henry, and welcome to lesson 4.13, Solving Linear Systems Algebraically. In the past two lessons, we've looked at solving linear systems by graphing. So we graphed the lines on a coordinate grid. We then found the intersection point of the two lines, and that intersection point was the solution. In the last lesson, we saw if the two lines were parallel, there was no solution. If the two lines were overlapping, there's infinitely many solutions because they were intersecting everywhere. Now that's all good, and hopefully you found it to be fairly easy. The problem is they're not always going to give you a coordinate grid. And using a coordinate grid is not necessarily the best method because some lines are really hard to graph. So we like this method of solving algebraically, and we're going to learn two different methods here. Some people really prefer one method, some people really prefer the other. I'm going to show you both methods throughout the lesson, and you can decide which method you like to use. I don't think there's going to be a time where I'm ever going to force you to use one method or another. I'm just going to give you a system of equations. I'm going to say solve. Now, if you learn both methods, there's definitely some times where one of the methods is easier than the other, but you can solve all the problems using either method. Okay, so don't feel like you have to learn both. It'd be nice if you did, but if you want to just focus on one and really learn one, you can. Okay, so warm-up is a type 1. It says, write 2 lines about what you know about systems of equations. So take 2 minutes, pause the video, do that. When you're ready to move on to the vocabulary, hit play, and we'll go on together. There is no new vocabulary, yay, but there's going to be some old vocab we'll talk about, so if you need refreshers as we're going through the lesson, some things you don't remember, just look back your vocab cards of the previous lessons. So let's get started. Alright, so we've seen previously that if we want to solve this system equation, if we want to find out what the x and the y value are that make both of them true, we could go through and graph them by solving or taking each equation, solving it for y to get into slope-intercept form, graph both equations, find out what the intersection point is, and that's the solution. But if you don't have graph paper, it kind of becomes a pain in the butt. It's not necessarily the quickest method. So what we're learning here is a new method called the substitution method. And if you just tried to come up with a solution. So we know the solution of here is an x-y pair, like 5, 3. You could check and plug in a number and check to see if it works, but the chances of you randomly guessing and checking a solution that works for both equations is very slim. So here's how this works. The general rule of solving an equation is this. You can't solve an equation if there's more than one variable. You can't. You cannot find out what that variable is if there's more than one. So what we need to do is we need to get rid of one of the variables. We need to get it so there's an equation with one variable in it. And the substitution method says this. If you get one of your equations, so it's like y equals or x equals, if you get the equation with the variable solved, we're going to take this and we're going to plug that into our other equation. Here's how. So I'm going to take this, and this is going to become x plus 2 times something equals 11. Now, this y, instead of me putting a y in here, which we already know we don't want 2 different variables. But we know that y equals 3x plus 2. It says so right here. Y is 3x plus 2. So instead of me putting a y down, I could put 3x plus 2. That's true, right? Y is 3x plus 2. So instead of y, 3x plus 2. And look what I have now. I have an equation with one variable So I can solve this. I can find out what that x is. That x might be equal to 8. And that's awesome. So let's do that. So let's distribute here. That would be 6x plus 4 equals x. So I distributed. I'm solving here. So I'm going to combine like terms. 7x plus 4 equals 11. Getting rid of this multiply is last, so getting rid of this add 4 is first. So I'm going to subtract 4 to cancel it out. 7x equals 7. Divide both sides by 7 and x equals 1. So we've found now that in our problem, our x value is 1. That 1 is a solution in both of my equations. So if I take 1 and I plug it into either of these equations, it will give me the exact same y value. I don't want to delete all this stuff yet, so I'm just going to move him off to the side. Delete that. All right, so I'm going to take the x value of 1 and I'm going to plug it into both equations. I want to show you that it gives you the exact same y value. So if I take and I plug 1 in here, 3 times 1 plus 2 equals y. Y equals, that's 3 plus 2 is 5. So we believe the y value is 5. The only way to be sure is if we plug that into the other equation as well. So I'm going to plug in 1 here for x. And let's play pretend we don't know what the y is yet. Equals 11. This blue stuff is still in my way. Group ye together. Oh, missed a piece. Group, get it away. All right. And if I solve for y and I subtract 1, 2y equals 10, and look at that. Divide by 2, y still equals 5. We found a pair of numbers that makes both equations true. If I would check this and I would plug in the 1 and the 5, we know it's going to work here because 3 times 2 is 5. Yay! We probably know it's going to work here. Hopefully you have faith it's going to work. 1 plus 2 times 5. 2 times 5 is 10 plus 1 is 11. This is the solution. We did it by substituting in from one of our variables. You could not have an equation with 2 variables. You could only have an equation with 1. So we said this y is equal to, well, it's the same thing as that y. It's the same letter. So if y is equal to 3x plus 2, let's plug in a 3x plus 2 in for y. And when you plug in a 3x plus 2 in for y, like we did here, and we distribute, and you solve, and you solve, and you solve, we found an x value of 1. That x value of 1 works in both equations. All we had to do then was take that x value of 1, plug it into one of our equations to find the y value, and we're done. We found the solution. Letter B. Now, in this equation, I'm going to maybe solve this second one. Simply because, just to tell you, you don't always have to solve the first equation. You can solve whichever one once you get practice, and you can understand these things a little bit better, but the ones that are easier. And I can see this first equation, if I solve for x, I'm going to get an easier time solving the problem. I'm not going to get fractions, essentially, is what it comes down to. But even if you get fractions, it's not the end of the world, and you can still do it. It's not hard math. It's just, if I could avoid fractions, why not? So I'm going to solve this guy for x. So I'm going to add 6y. 3x equals 6y plus 36. And divide both sides by 3. X equals 2y plus 12. All right, so now I know that this x right here which is the same as this x right here, it's the same variable, x is equal to 2y plus 12. So if I plug in a 2y plus 12 in right there, I'm going to have an equation with only one variable. So 3 times 2y plus 12 minus 2y equals 12. I have one variable. I have just y's over here. I don't have any more x's. So when I solve that equation, that's going to tell me the value for y. And then we'll use that value for y to find the value for x. So let's get to it. We're going to solve this thing. We're going to get the y by itself. So distribute 6y plus 36 minus 2y equals 12. Combine like terms is 4y plus 36 equals 12. Subtract 36. And yes, I'm going a little bit quickly in my solving of the equation because it's kind of old stuff by now. Hopefully you have a good understanding of how to solve an equation. That's negative 24. Divide by 4 on both sides, and y equals negative 6. So if the y value is negative 6, what's the x value? Well, all we have to do is, since the y value of negative 6 is true for both equations, negative 6 is going to be the y value we're going to use. All we have to do is plug in negative 6 in one of the two equations we've done to find the x value. Heck, I can even plug it in right here. Watch this. X equals 2 times negative 6 plus 12. X equals, this gives me negative 12 plus 12. X equals 0. So the x value of 0, the y value of negative 6 is the solution to our problem. Lots of little steps, a whole heck of a lot of algebra, solving equations, manipulating equations, getting variables by itself, but that's what algebra is all about. And if we wanted to, I don't think I'm going to do it in this problem just to save some time, but if we wanted to, we could also go through and check our solution. We could plug in 0 for the x and 0 for the y and show that it works in both equations, but trust me, it does. Here's one I'd like you to try. So go ahead, pause the video, do this problem on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so this equation here is already solved for y. That makes our lives easy because now I can say that this y, which is the same as that y, is equal to x minus 7. So when I substitute, which is why it's called the substitution method, I substitute x minus 7 in for y. I now have an equation with only one variable, and so I solve. Distribute 3x minus 21. Combine like terms, 5x minus 21. Add 20 to both sides. 5x equals, add 21. My brain was ahead of me. I knew the answer was going to be 20. Divide by 5 on both sides, and x equals 4. So we found an x value of 4 that will work in both equations. Now all I have to do is find the y value. So if I plug in an x value of 4 here, I can find the y value. And the y value is negative 3. So I found the x and the y that makes both of these equations true. Okay, another example for me. This is letter D. Let's see. See, this one here, it's already solved for x, the first equation. So I'm going to use that. I'm going to take that and I'm going to say, okay, so I don't have to do an extra step. I'm just going to plug that in for the x. And what that gives me is an equation with only y's in it that I can now solve. It's not a pretty equation. In fact, it's pretty ugly, but it's still solvable. So we'll start by distributing, get positive 20y minus, let's pull out our calculator, 39 times, 39 times by 5 negative is negative 195 minus y equals negative 43. Okay, this is positive, just so I remind myself, because it looks like a negative there. Combine my like terms, I've got negative 1 and positive 20 gives me a positive 19y. Getting the y by itself, we're going to add 195. 19y equals, because these signs are different, we're going to subtract them. So 195 minus 43 equals 152, and I hope that divides evenly. If not, it's an ugly fraction. Divide by 19 equals y equals 8. Awesome. Okay, so we have found a y value of 8 that makes this statement true. So now all we have to do is plug in that y value of 8 into our equation to find out what the x value is. Negative 4 here, x equals, okay, so x equals, this gives me negative 32 plus 39, x equals positive 7. So my coordinates of 7, 8, or the x value of 7, the y value of 8, is what makes both of these equations true. Here are the last two we're going to be using the substitution method. So go ahead and do these two right now. Pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so first one's already solved for y, so I can just take this information and plug it in for y. So that can give me 5 times negative x plus 7, there's the y, plus 4x equals 32. And then we solve our equation for the x. We distribute negative 5x plus 35 plus 4x equals 32. Combining like terms gives me a negative 1x. 35 equals 32. Subtract 35 on both sides gives me negative 1x equals a negative 3. And finally divide by negative 1. X equals 3. Alright, so I've found the x value of 3 that works in these equations. Move him over here. Maybe move him down a little bit. Alright, so the x value of 3. So if I plug in 3 into my equation for the x value, I can find my y value. And I'll be honest, I could plug in 3 into this equation as well, but this one's just easier. It's less stuff, it's simpler. I only have to do one step, just negative 3 plus 7 is 4. And I got my answer. If I did it over here and I plugged in 3 here, I'm just going to have to do more steps to get the same answer. I'm still going to get y equals 4. So in this problem, the solution is an x value of 3, a y value of 4. Can I move him back? I'll just move this stuff further down. So there's the first problem. Okay, letter F. Now, let's see here. This one looks a little Weird, because this is x equals this stuff. This is x equals this stuff. So what do I do? Should I solve for y and then plug the y in? I guess we don't have to, because if you look at this x is the same thing as this x. So if I plug, for example, plug this information in here, it's essentially saying that negative 2y minus 6 is equal to negative y plus 2. This is equal to x, and that is equal to x. So if I set them equal to each other, look at that. I don't have any more x's. My x's are gone. So I can solve this equation, variables on both sides, but it's the same variable. I have just y's, one variable, which means I can solve this and I can find out what the y is. So let's do that. There's no distributive property, no combining like terms. Add y gives me negative 1y minus 6 equals 2. Add 6 to both sides, negative 1y equals not 4, Mr. Henry, 8. Divide by negative 1, and y equals negative 8. All right, so I've found the y value is negative 8. So in order to find the x value, all I have to do is plug that y value into one of my equations. And I'm going to use this one over here because it has more space to work. So x equals negative y plus 2. The y value is negative 8. Negative 8 is positive 8 plus 2, and that equals 10. So I have the solution 10, negative 8. There's my x, there's my y. That is my answer. 10, negative 8, x is 10, y is negative 8. Okay, so this is solving a system of linear equations by substitution. Our goal in this problem, the reason why we were substituting, is because we wanted to get rid of one of our variables. So if we solved for a variable, plugged it into the other equation, like we did, then we were left with an equation with only one variable. We solve, and we find out what that variable equals. Once we knew what one of the variables were, we could plug that in to an equation and solve to find the other variable. If you could please, briefly list the steps needed to solve a system of linear equations using the substitution method. Well, I kind of just did that. You have to take one of the equations and solve for a variable first. Once you have one equation solved for a variable, x or y, you take that, plug it into the other equation so that you only have an equation with one variable. Solve your equation to find the value of one variable. Once you have the value of one variable, you plug that into an equation and solve to find the value of the other variable. So that's what we did in the past 6 problems. Something like that. Now, the other method of solving equations algebraically is called the elimination method. Or I say the other method we're talking about is called the elimination method. I'm sure there's more. Now, the elimination method essentially comes down to you're going to look at both of these equations together. Instead of taking one equation, solving it, and plugging it back in, and solving that equation, and taking your answer and plug, we're going to kind of treat it like one big math problem. Watch this. And this elimination method has the same goal. You still cannot solve an equation if you have two variables. Both of these equations have two variables. But watch what we're going to do. If I say I'm going to add these two equations together, And there's a reason why I'm adding. And yes, addition is the correct method here. Watch what happens. A positive 2 added to a negative 2 is 0. This piece cancels out. It is eliminated. 0 x's. 3 plus 5 is 8 y's. 11 plus 13 is 24. Don't need the 0 x's. Divide both sides by 8. Y equals 3. My brain shut down for a second. So y equals 3. We then can take that and plug it into one of our equations. I'll use the bottom equation just because it's there. Negative 2x plus 5 times the y value of 3 equals 13. Solve for x. That's 15. That's 13. Subtract 15 on both sides. Negative 2x equals negative 2. Divide by negative 2 on both sides. X equals 1. So I found the point 1, 3. And you're thinking in your head right now, Mr. Henry, you said that most people use the other method. So this one was so much quicker. Look at that. That was much less work. The problem is this one happened to be set up nice and pretty where you could just add them straight up and down and one of them already canceled out. Most of the time that doesn't happen. If we look back at some of our other equations, if I would set these up and down, y equals negative x plus 7 and 5y plus 4x equals 32, that doesn't work. And I can rearrange it a little bit with some manipulating of the equations. Becomes y plus x equals 7 and 5y plus 4x equals 32. But that's still, if I add, I get 6y's and I get 5x's and I get 39. So it can be simpler, but most of the time it doesn't work out. Unless you're given nice, pretty equations, kind of like these are already set up. Look at this. Here's another one where if you look at it, you see how these have the same coefficient, 3x, 3x? If I could like subtract these, say 3 minus 3 is 0, that would be awesome. And the actual thing is we can. If we just take the top number minus the bottom number, 3 minus 3, 0, gone. 2 minus, remember we're subtracting, 2 minus 5 is negative 3. 45 minus 72. Just to make sure we're right. 45 minus 72 equals negative 27. That one worked out nice and pretty because everything was set up and it's kind of designed to be using the elimination method. Just like this problem is designed for the substitution method because it's already y equals. And we're going to solve here. We want to get this y by itself, so divide by negative 3, divide by negative 3, y equals 9. That's one variable. And to find the solution, you just simply plug that into one of your other equations. And I'm, again, going to use, I'm going to use the top one because the numbers are smaller. 3x plus 2 times 9 equals 45. That's 18. That's still 45. And that's 3x. Subtract 18. 3x equals 45 minus 18 equals 27. Divide by 3 on both sides, and x will equal 9. So in this case, I have the solution 9, 9. Both the x and the y value were 9. Now, if you look at this method, or this problem here, I no longer have a nice pretty system of equations. Look at this. If I add, this does not cancel. This does not cancel. If I subtract, this doesn't cancel and this doesn't cancel. So it almost looks like the elimination method doesn't work. But it does. It's just going to take a little extra step or two. So what we need to do is we're going to make them eliminate. If I take this whole top fraction and I multiply by 4, everything on the top fraction, or the top problem, I said fraction, the top equation, and multiply by 4, watch what I get. I get negative 12x. That's 4 times negative 3. Actually, it'd be, yeah, negative 12x. And 4 times 3y is positive 12y. And 4 times negative 3 is negative 12. Can I have this in another color? I want it in a different color. Red, and I'm just going to erase that part. Minus 12x in red. That way you just keep it separate. So I multiplied by 4, and this is what I got as a result of multiplying by 4. And why on earth did you do that, Mr. Henry? Because if you look at this bottom equation, 12x minus 5y equals 33. Look at that. By me multiplying the whole top equation by 4, now I have similar coefficients. They're different signs. One's positive, one's negative, which is fine. And now I can use this elimination method. Now, before I go through and do this, just as a side note, you might be thinking, wait, Mr. Henry, does that mean I could have taken, let me erase a little bit. Does that mean I could have taken this bottom equation and multiplied by 3, and the top equation and multiplied by 5? If I do that, negative 15x plus 15y equals negative 15, and 36x minus 15y equals 99. The answer is yes, because look what we do here. If we multiply the top one by 5 and the bottom one by 3, this would now eliminate. I have a positive 15 and a negative 15. So those y's would eliminate, and I'd be left with x's. I could solve the equation, get my answer, and both of these problems here are going to give us the exact same solution because they're both from the same set of equations. Okay? So this is the little extra work needed to solve equation using the elimination method. Well, let's do this. I'm going to do the top equation here. So if I eliminate, so to eliminate these, I need to add them, because a negative 12 plus a positive 12 is 0. 0 x's, they're gone. A positive 12 plus a negative 5 is 7. And a negative 12 plus a 33, just to double check, negative 12 plus 33 is 21. Then we solve, divide by 7, y equals 3. And then we could take that y equals 3 and plug it back into one of our equations. I'm going to use the top equation just because the numbers are smaller. So negative 3x plus 3 times, we said y is 3, equals negative 3. And that is 9, negative 3x, minus 9 on both sides. These cancel. Negative 3x equals negative 12. Divide by negative 3. And we have an x value of negative 4. So we get the solution negative 4, 3. Now, just for giggles, let's solve the second one here. So I already said that this would eliminate if we add, because the signs are different. So if I take a positive 15 and I add a negative 15, I get 0 y's, which cancels. Or just, we don't need it. If I take a negative 15 plus a 36, I'm going to get, let's see, it's a 15 negative plus 36 equals 21x, and a negative 15 plus a 99 equals 84. As I'm looking at this, this is going to give me an answer of divide by 21, divide by 21, x equals 4, which makes me think, what did I do wrong here? And actually I do see it. My 3 and my negative kind of blended together. This should be a negative 3, and negative 12 divided by negative 3 is a positive 4. So, see, it's a good thing I checked my work. So it's actually positive 4, 3, not negative 4, 3. And then since now I know the answer, the x value is 4, I could take that x value of 4 and plug it into one of the equations and find the y value of 3. And I might as well check it just to make sure I did it right. So 3 times the x value of 4, I'm using this top equation, plus 3y equals negative 3. That's negative 12 plus 3y equals negative 3. Add 12, 3y equals 9, divide by 3, y equals 3. Is that what we said it should be? Good. So I showed you if you do the problem either way, you get the same answer. So this is the elimination method. You try to eliminate a problem or a variable. If they're nice and pretty and you can just add or subtract them, do it. If they're not nice and pretty and you have to multiply by something first, do it. Now, I will say, later on, I don't think there's going to be problems that say, solve this problem using the elimination method, or solve this problem using the substitution method. It's going to say, solve the system of equations. You can do the way you like. If you really like using the elimination method, use it. If you really like substitution, use it. Heck, if you really like graphing and you want to sit there and you want to draw yourself a little graph space and you want to go through and find the intercepts and slopes and find the intersection point, you can do that too. There's absolutely nothing wrong with using it. So use the method that works best for you. All right, so here are the last 3 problems for the day. So what I'd like you to do is pause the video and do them on your own right now. When you're ready to continue, hit play, and we'll go through them together. All right, so first thing I'm going to do is I'm going to check to see, does anything eliminate right away? 5 and 3, no. 4 and 4, yes. If I add a negative 4 and a positive 4, they cancel. So I'm going to add these equations together. 5 plus negative 3 is 2. Negative 4 and positive 4 equals 0, so I'm just not even going to write it down. And 4 plus negative 34 plus negative 30 is 4. Divide by 2 on both sides, x equals 2. Okay, so I have the x value is 2. I'm looking for the y value. So I'm going to take that x of 2 and plug it into one of my equations. I'm going to use the top one. So 5x minus 4y equals 34. The x value is 2. Give me some more space. That's 10 minus 4y equals 34. I'm going to subtract 10. Negative y equals 24. Divide by negative 4 on both sides, and y equals negative 6. So when the x value is 2, the y value is negative 6. Okay, letter E. I first check to see if anything eliminates, and I see these x's have the same coefficient. So if I would subtract that, just like if you had 4 minus 4 equals 0, well, the negative 4 minus negative 4 equals 0, because minus and negative keep flip change, becomes a positive, and yeah. So I'm going to subtract everything on the bottom by the thing on the top. Now, one thing that might help you out to do this is when you do this, you could actually go through and you kind of like multiply everything down here by negative 1. So times by negative 1, flip, times by negative 1, flip, times by negative 1, flip. And now we can do an addition. That cancels out 0x, negative 1, and positive 3, or negative 1 minus a negative 3, still gives you 2y. Third, negative 36 minus a negative 28, or negative 36 plus 28. 36 negative plus 28 equals negative 8. Divide by 2 on both sides, and y equals negative 4. So there's our y value. If I take that y value and I plug it into one of my equations, I will get my x value. So which equation do I want to use? Well, it doesn't really matter because there's tons of negatives everywhere. So I guess I'm just going to use the top one. Negative 4x minus a negative 4 equals negative 36. Minus a negative 4 becomes plus 4. Negative 4x plus 4 equals 36. I don't know why I wrote it so far over. Let's keep things lined up, Mr. Henry. Subtract 4 on both sides. Negative 4x equals 32. Divide by negative 4, and x equals negative 8. So we have our solution of negative 8, comma, negative 4. And finally, the hardest of the bunch, simply because when you first look at it, nothing cancels. There are no common variables. I guess you could say, I can't make a straight line. Straight-ish. Alright, I could say that these 30s cancel, but that doesn't help me out. Our goal is to get rid of one of the variables, not that constant. So I need to do some algebraic finagling. Multiply some stuff together. So what could I do? Well, I could take, if I took this guy times by 2, that would be 8, and then my 8s would cancel. Or I could take this one, this y, and times by 5, and that would cancel. So those are my two choices. I could times everything on the top by 2 or everything on the top by 5, and then they would cancel. I'm going to multiply by 2 because it's smaller, and I'm going to get smaller numbers. So that gives me, times by 2 is 8x and plus 2y and negative 60. So 2 times 4 is 8. 2 times y is 2y. 2 times negative 30 is negative 60. I multiplied everything on the top by 2. The bottom stays the same. 8x plus 5y equals negative 30. Now, this will eliminate. I put my minus sign there because I know I want to subtract these. I want to take 8 minus 8 is 0. 2 minus 5. And you could actually do that same trick we did in the previous problem. If you're doing a minus, you can just quickly go through and change the sign of everything. So minus, that becomes a negative 5 and a positive 30. Say, okay, 2 and negative 5 is negative 3. negative 60 and positive 30 is negative 30. You get the same answer either way. It's just a preference of how you like to do it. And divide by negative 3, divide by negative 3, y equals positive 10. So I have a y value of 10. To find the x value, I need to plug that into one of my other equations. I'm going to use the top one because the numbers are smaller. So 4x plus 10 equals negative 30 minus 10. 4x equals negative 40. Divide by 4. Cancels x equals negative 10. Negative 10. So those are my x and y values that make this system of equations true. So this question asks, what does it take to eliminate one variable in a system of equations? So using this elimination method, what did you have to do? And hopefully you said something like, well, to make one of the variables eliminate, they have to have the same coefficient between the two equations. So if they have the same coefficient, like they did here, they both have a 4, or here they both have a 4. If they have the same coefficient, you simply add or subtract the equations together, and that eliminates that particular variable. And if they don't have the same coefficient, like here in letter F, they had different coefficients, you can multiply one or both of the equations by something, a constant, to make them have the same variable, the same coefficient, I should say. And then they cancel out, and you can continue doing your elimination method. All right, for our summary, we have a type 1. Which method of solving equations algebraically do you like best? So do you like the substitution method, or do you prefer the elimination method? And why? Simple as that. Go ahead and pause the video if you need a little bit longer. If not, this has been lesson 4.13. Thanks for watching.